Today, 7 questions in section B. Without further ado, let's get going. All right, first of all, teacher, you are, okay, if there's any technical issues, you can move to our WeChat or YouTube, like the alternative channel for the viewing. Okay, so with that, let's first start off with something pretty fun, pretty chill, right? We are counting triangles. Now, counting 2D shapes is something that often appears in your lower primary competitions. Let's take a look at this question here. Now, how many triangles are there over here? Right, quickly show me. How many triangles are there? How many triangles are there? Are there only 1, 2 triangles? No, it's not just 2. It's actually 3 triangles, right? Why are there 3 triangles? That's because you have, let me adjust my pen. You have 1 over here. Okay, then you have 1 over here. And then you have this whole big triangle, right? Let me use another color to show you. One big triangle. All right, so that's why you have 2 plus 1 equals to 3, right? 2 plus 1 equals 3. And the next one, how about this one? Is it 4, right? 1, 2, 3, and then the big 4. Is it case? Well, no, actually not, right? It's 3 plus 2 plus 1 equals 6. Where is my 3 plus 2 plus 1 from, right? We have 3 small triangles. This one everyone knows. Okay, and then did you notice that this is also a triangle? And this is also a triangle. So we have 2 medium triangles. And also finally, everyone should notice by now, the big triangle. All right, so that's why we have 6 triangles in total. Now, actually, other than listing out the triangles one by one, we can think about it like this, right? When we see these sorts of triangles with all the lines pointing towards a certain peak, right? So you can think of this triangle as a mountain, and there's a certain peak on top of the mountain. Okay, so all the lines with one ending point, they all shoot up to the same peak on top. So all the points on the base, on one of the sides, they all shoot towards the peak at the opposite, right? Whenever you see triangles like this, like you see this side, all the points, all the lines, okay, start from points on this side, and they all shoot towards the opposite peak, right? So in this case, this type of triangles, we can use another way to do this, right? How can we do this? Now you see all the points over here, right? They are on the same base. And if you choose any 2 of them, then you shoot up together. For example, I choose this point and I choose this point. I shoot up, right? I shoot up like this. Today's tablet is a bit wonky, right? If you do like this, then you can form a triangle, right? So any pair of points that you choose, you can form a triangle by shooting them up to the same peak. So this question now becomes how many pairs of points that you can select, right? My MEJ kids have learned this in term one. My CO kids have learned this in last lesson, right? This is the shooting method, choosing number of pairs, right? So if you have 3 points below, then you start shooting from 2, right? Because on the right, let's say from this point onwards to its right, we have 2 points to choose, so 2 pairs are formed. From this point onwards, shooting to the right, 1 pair can be formed, 0 pairs. When there are 4 points, right, starting from the leftmost point to the right, 3 points can be selected, 2 points, 1 point, 0. So 3 plus 2 plus 1, 6 pairs. So likewise, can you tell me, what if I have 5 points on the base, right? So what is the number of triangles you can form here? Oh, this is question 17, but we are preparing for question 17, right? So you see, starting from the point at the leftmost, there are 4 points to its right, 3 points, 2 points, 1 point, 0 points. So the total number of pairs is 4 plus 3 plus 2 plus 1 equals 10. All right. Likewise, the 4 also comes from there are 4 segments, right, that the side has been divided into. Likewise, in this triangle, right, we have 5 line segments. Okay, so it's 5 plus 4 plus 3 plus 2 plus 1 equals 15. All right. Use a ruler. Okay, also can. Right. So when we are counting the triangles that share the same base, meaning when all the points are on the same side, then we can use the shooting method on the line segments. right? The shooting method simply involves starting from the left, shooting to the right. How many pairs can you form? How many points to the right you can shoot to, right? So you start from each point, and then you see, oh, how many points are to its right? 4 points to its right, 3 points to its right, 2 points to its right, 1 point to its right, so on and so forth. And you add up the total number of pairs. Okay, so this is part 1. How about this one? Can I use shooting method over here? Right? Can I use shooting method for this triangle? Now, the difference between this triangle and the previous triangles are, of course, I still have points lying on the same side. Right? Oops. I still have points lying on the same side, but are they shooting towards the same peak? Are they shooting towards the same opposite point? They are not, right? So instead, the triangles are in layers, right? If they are in layers, then you need to count layer by layer, right? So how many layers or how many triangles are there? Right, so there's one triangle, teeny tiny on top, but if we combine with the part below, there's one more triangle, and then combine with the part below, one more triangle, combine again with the part below, another triangle. So we have one, 2, 3, 4. 4 triangles in total, right? So if your triangles are arranged in layers, we just count from top to bottom. Okay, and if you see, this looks like a pyramid, or it also looks like a carrot, right? An inverted carrot, right? So if you see such a carrot shape, just count from the top to the bottom. And then now we enter this question, right? There are how many triangles in the figure below? All right. So first of all, you see that this actually looks pretty familiar with what we have shown you just now, right? Where you can use the shooting method directly, except there's a pesky little line at the middle. Right, so we can make our life easier by first removing the line, right? Let's assume, or let's just ignore the line in the middle, right? What if we are only given with such a basic shape? There is a line, but we ignore it first, right? Let's ignore the line, and then we find out, how many triangles are there here? In this basic shape, you notice that all the points are shooting towards the peak, right? The opposite point, which is the peak on top. So we can use the shooting method. Shooting method, arrange the points in a row, start from the left and see how many pairs it can form by shooting to the right. Now, the point on the left has 1, 2, 3, 4, 5. 5 points to its right. So it can form 5 pairs. Okay, now the next point over here has 1, 2, 3, 4. 4 points to its right. So there are 4 new pairs that can be formed. I don't need to go back to the left because I have already chosen this pair when I considered the previous point. Right. So likewise, 3, 2, 1, 0. These are the number of points to each of its right. And finally, you add them up, and that is the number of triangles that you can find in this basic shape. So there are 15 triangles in total. Right. But before you write down the answer 15, please remember that there's actually a line in the middle. Right. So now that you insert back the line, you divided the big triangle into 2 parts. Right. After adding the line, you divided the triangle into the top part, which I am now outlining using green, as well as the bottom part, which I am outlining using pink. Okay, like this. All right, so now let's take a look at each of the parts separately. Now, once we add a line, let's look at the top layer. In the top layer, in this big triangle, again, you see that all the points, there are a lot of points along one side of the triangle, and they are all shooting up to the opposite peak. So again, you can use shooting method. Okay, how many points are to its right? 5 to its right. 4 to its right. 3 to its right. 2, 1, 0. So again, 5 plus 4 plus 3 plus 2 plus 1 plus 0. So that will be 15 triangles. All right. And then what about the bottom? Can I still use the shooting method for the bottom layer? Actually not, right? Because you see, even though I have a side with a lot of points on it, these points are not shooting towards the opposite point, the opposite peak. So we can only treat it as a carrot, right? It's a carrot shape and count how many layers there are. there are 1, 2, right? So let me use my mouse instead. 1, the smallest triangle here, combined with the quadrilateral next to it. 2, 3, 4, 5, right? So there are 5 layers in this carrot. So there are 5 triangles only. Okay, so with this, we have found all the big and small triangles in different parts. In total, we have 15 plus 15 plus 5, which is 35 triangles. Okay, so there are 35 triangles in total, and this involves shooting method and also counting by layers, right? Two very useful tools when you see certain patterned triangles. All right, so this is a review for both MHA and CO, right? Somehow related to your long-term course lesson. Hopefully, it's been a useful revision. Okay, that being said, let's move on to our next question, which is on comparison and replacement. Now, teacher Yong was a bit evil here because I made this sort of like a chicken rabbit problem, right? But let's read the question to see what it's actually talking about. Now, there are some chickens, rabbits, and cows in a huge farm, right? Very huge. When Natasha asked how many animals of each type are there, the farmer replied, there are 360 chickens and rabbits, 251 rabbits and cows, and 401 cows and chickens. How many legs do the animals have altogether? Right, so my CO kids, comparison and replacement, you have just learned it before. And for my MHA kids, actually, this is sort of related to your shapes and equation as well, right? The format of this question is a bit similar. Right, but we see so many words. Let's first convert it to equations, right? Whenever you see a lot of words, try to convert it to either pictures or equations to make your life easier. Okay, so let's use symbols for different animals, right? Let H to be chickens, C to be cows, R to be rabbits. Now, when you have two types of items starting with the same letter, please do not just say chicken is C and cow is C. All right, it will confuse you even further. Use a different letter for each type of animal. And since we are asking how many legs are there, let's just find out how many legs there are as well. So how many legs does a chicken have? How many legs does a chicken have? A chicken has 2 legs, okay? A cow has 4 legs and rabbit has 4 legs. Okay, so when I say 360 chickens and rabbits, I don't mean there are 360 chickens and 360 rabbits. I mean that the total number of chickens and rabbits is 360. So the first equation, H plus R, chickens and rabbits is equal to 360. Right, problem. Okay, it's a comparison 51 rabbits and cows, right? So cows and rabbits, 251. Finally, cows and chickens, so H plus C, 401. Now, you might use your usual method, right? You see, there are 2 chicken copies, 2 cow copies, 2 rabbit copies to solve this problem. But there's actually something special over here. Do you notice that 2 types of animals have 4 legs? Right. So if you know that both cows and rabbits have 4 legs, you don't even need to find out individually how many cows and how many rabbits there are. You can straight away find out there are 1,004, right? We have 1,004 legs coming from our chickens, from our cows and rabbits. Okay, from cows and rabbits, I have 1,004 legs altogether. But then I still need to know, where are my chickens, right? How many chickens are there? Right. You know, it adds up to 251. You already know it's 251. Right. So you can replace, which is 761. So 2 copies of chickens, 1 copy of rabbit, 1 copy of cow adds up to of chickens. 251 is 761. So then 2 units of chickens will be 761 minus 2 divided by. But remember, are we really interested in the number of chickens? We are interested in the number of legs. And how many legs does each chicken do? To find the number of chicken legs, right? I have 510 divided by 2 number of chickens. To find the legs, I still need to times 2. And finally, to find the total number of legs, you can just take 19. This overlapping point, right? The real length is length of the overlap total. But then you also need to observe very carefully. What is the overlapping part? Okay, so the first part is easy, right? What's the total number, what's the total length of all the 5 chain links? So the length of 5 chain links, right? Let me write it clearer. Right, so be very careful, right? 1 centimeter is equal to how many millimeter? Centimeter is equal to, yes, it's equal to 10 millimeter, equal to 1 meter is equal to 100. 5 centimeters is equal to 25 times 10, right? 1 centimeter is 10 millimeters. So 25 centimeters is equal to 250, right? 250 millimeters. Okay, and now we know that 5 chain links is 250 millimeters, but there is an overlap, right? You need to overlap a bit to link the 2 chain parts together. Okay, so when it comes to observing the overlapping part, my key tip for you is to really draw the picture carefully using a ruler if you have one, right? Better bring one to TASMO though, right? You will need it for accurate measurements, etc. Right? So with that, let's try to see what happens if we draw out 2 chain links together, we find the overlapping relationship. So now teacher Yonglam is drawing across 1 chain link. Then I'm going to move the ruler down a bit and draw for the other chain link. Once you finished drawing the chain link, right, the 2 chain links, you draw a line for them. Now you can observe the parts that I'm coloring in green now is actually the overlapping part. Not sure if you're seeing clearly, right? My overlapping part is here. Now, this is my overlapping part. Now, the question gave, okay, one such thickness of 1 chain link is 8 millimeters. Does that mean each overlapping part is 8 millimeters thick? Now look carefully. The overlapping part consists of 1, right? Let me use a different color. It consists of 1, 2 thicknesses of the chain links, which means each overlapping part is not just 8 millimeters, but 8 plus 8 equals 16 millimeters. All right, 8 plus 8 equals 16 millimeters. So with that, that is the length for 1 overlapping part. But how many overlapping parts are there, right? Be very careful. Observe the picture or use your understanding of intervals, right? The overlapping parts are between your chain links. So there is 1, 2, 3, 4 overlapping parts, right? So each overlapping part is 16 millimeters. So the total length of the overlapping parts, the total overlap, there are 4 such parts. So 4 times 16 millimeters, which will give you 64 millimeters. So this is the overlapping part that you double counted, right? They are overlapped. You need to subtract them to remove the overlap. Right, so originally, this is 1 chain link, this is another chain link, right? Once they overlap, then you double counted some of the lengths, right? You double counted the 16 millimeters when you just do 5 times 5, 10 times 10. So we need to subtract the total overlapping part to get the actual length of the chain, right? So the actual length will be 250 millimeters minus 64 millimeters, which is equal to 186 millimeters, right? A lot of the students couldn't get this. Each overlapping part is 60 millimeters, right? Or they don't know what to do with the overlapping part, right? When there is an overlapping part, you need to subtract, okay? You need to do the subtraction. Subtract 1 copy of each overlapping part to get the actual length. So my answer is 186 millimeters. Okay, now with that, that is question 19. Actually, the key point is to just really observe the diagram carefully, right? As well as in other word problems. Similarly, right? Carefulness is one of the key attitudes you must have. Okay, this is question 20 now. We are talking about enumeration, right? Enumeration means listing. And for my fellow MHA kids, yes, you have seen this before. This is what you have just learned. Okay, okay, so now there are some 3-digit even numbers. Now I admit, Okay, I was a bit evil by adding this even number here, right? So it's one more condition that you should check, which is why, right, you should be very careful when reading the question, because maybe the real important keyword is only that one word hidden somewhere. All right. So we want to list out 3-digit even numbers. The digits in the ones place is 4 less than the digits in the tens place. The digit in the hundreds place is 1 more than the digit in the tens place. What is the sum of all such 3-digit numbers? Nope, Teacher Yonglam is not asking you to list them all. Teacher Yonglam is asking you to find the sum of all of them, right? Yeah, it's pretty evil, but yeah. Using this question, I'm reminding you, read the questions properly, list things out carefully. Now, how do we list numbers? When the question has already given you that we are looking for numbers with a certain number of digits, right? 3-digit number, 4-digit number. Most importantly, you need to label the place values, right? Give the correct number of seats for us to put the digits in later. Here we are looking for 3-digit numbers. So it's my hundreds, tens, and ones, right? So you can write the full name, or you can do just like me, right? Hundreds, tens, and ones, HTO. Okay, and then now we know that there is a relationship between the different digits in the different place values. So we need to use a clue bridge, right, to show the difference between the different digits. Okay, so we have the ones, we have the tens, we have the hundreds, right? So how I usually like to draw the clue bridge is to start from the smallest one to the largest one. So in the hundreds, tens, and ones, which one is the smallest? Right. We can actually draw a magic arrow to compare the relationships, right? This is a key technique in logical reasoning, right? To compare different things, we will use a magic arrow like this, right? To arrange them. So we want to find out which digit is less, which digit is more. Now, while I am demonstrating, can you tell me hundreds, tens, and ones, which place value has the smallest digit, has the least digit? Okay, which one is it? My ones place is 4 less than the digit in the tens place. So my ones place will be on the far left, which is the less part. And my tens place will be 4 more than it. So with a difference 4, we label. Then the hundreds place is 1 more than the digit in the tens place. Hundreds is even more than tens. So I'm going to put it even towards the right. And the difference is 1. And with that, do you know where should I start drawing the bridge? Okay, I should start from the ones place, right? The ones place is 4 less than the tens place. So what we will do is, yes, we will draw ones, 2 tens, right? We start from the smaller place value digit to the larger one. The ones digit is smaller than the tens. So we draw from ones to tens and we do a plus 4, right? This step is important so that you remember every time we list out a ones, what should you do to get the tens? And likewise, tens will need to plus 1 to get to the hundreds. Okay? And now we have figured out the relationship between the ones and the tens and the hundreds. It's time to list the numbers out in order. All right? So first off, we will again list from the smallest digit to the biggest digit, right? We should start from ones. Right. What's the smallest possible ones digit we can have? Can I start from 1? Hey, no, remember, 0 is a special digit, but it only cannot appear at the highest place. My ones, I could start from a 0, and then we move on to listing the next number. What is the next number I should list? Yes, it's the magic arrow, yes. Should I start from 1? Should I list 1 now? Hey, read the question carefully again, right? Okay, so we want even numbers. So we should not start from 1, we should start from 2 next. And then 2 plus 4 is 8. 8 plus 1, 2 plus 4 is 6. Now you see calculation, very important, need to be careful. 2 plus 4 is 6, 6 plus 1 is 7. Okay, hopefully I didn't scare you over there. Okay, moving on. The next ones digit I can start from is 4. Right, 4 plus 4 is 8. 8 plus 1 is 9. Okay, and when you see 9, Do you think you can start from a bigger ones digit now? Can I start from a bigger ones digit now? Cannot. Okay, because you see, if I have 6 over here, 6 plus 4 is 10. Hello, 10 is not even a digit. Right, so we will just stop here. No point listing it as well. Okay, so these are the numbers I have. And the final step is to find the sum of all such 3-digit numbers. Right, addition, pretty simple. Okay, pretty foundational. You should be able to do this. Okay, make sure you do your calculations carefully. You wouldn't wish to end up doing the last step wrong. So 0 plus 2 plus 4 is 6. 4 plus 6 plus 8 is 18. Then finally, 1 plus 5 plus 7 plus 9, 22. Right, so as some of you have eagerly told me the answer, yes, 2286 is it. All right, so that's enumeration in number groups. For my MHA kids, you have learned this before. Okay, so hopefully this is a good refresh for you. All right, and now let's move on to the next question. Oh, you see snail and well again, right? It's another snail climbs well problem. Okay, and hopefully you realize, right, which question is it. Okay, a snail wants to climb out of an 8-meter burrow and it climbs out 4 meters during the day and slides down 1 meter at night. Right, so my burrow is 8 meters deep. Every day, the snail will climb up 4 meters and then slide down 1 meter. Right, now previously when we talked about snail climbs well problem, I am actually assuming something. I am always assuming that I am starting very well so that the last day I can climb the full distance and just nice escape the burrow or the well. But let's see if this is the case today. My snail starts from the bottom part of the burrow, and on the first day, I will climb up 4 meters, right? I will climb up 4 meters. Let me draw slightly better to scale. Right? I will climb up 4 meters, and then I haven't reached the top. So I will minus 1 meter, right? I will fall down 1 meter. So after the first day, this snail is at the 3-meter mark. Okay, now let's move on to the second day, right? On the second day, I start from the 3-meter mark and I climb 4 meters up again. So it's a +4, but then I have not reached the top because 3 plus 4 is 7, not 8. So unfortunately, the night has come. So the snail, the poor little snail, will have to slide down 1 meter again, right? So -1. Okay, and now where is it at now? 3 plus 4 is 7. 7 minus 1 is 6. So it's now at the 6-meter mark. Okay. Now, on the third day, the snail tries to come out of the burrow. My question is, do you think the snail needs to climb up 4 meters? Does the snail need to climb up 4 meters to escape? I don't, right? I actually just need to climb part of the 4 meters, right? It's actually 8 minus 6 equals to 2 meters left. As long as, or rather as soon as I have climbed the 2 meters, I can escape the well or the burrow, right? So the moral of the story here is, this time I introduce you a different type of snail climb well problem where we do not always climb the full distance upwards on the last day. Right. Previously, on the last day, when I say I can climb up 4 meters, I really climb up 4 meters. Right. I really +4. I really +4 on the last day. So this is something to take note of. But something still remains the same. On the last day, do I actually fall down? Right. Do I fall down on the last day? This is question 23 by the way. Do I fall down? No, I don't. Right. My last day is special because I will never fall. Right. I only go up and then I escape. Which bears the next question. If I already know I am going to climb up of an 8-meter burrow and I can climb up 4 meters during the day. If I want to escape during the next daytime, let's say night has falls and then I rest and then the next day I need to escape. During the daytime, right? I just go up, I don't fall down, I can escape. Then the snails need to be at least how many meters away from the ground the night before? To be able to escape during the next daytime, the snail needs to be at least how many meters away from the ground at the night before? Now think about it. You are almost there, right? You can reach 8 meters at the next daytime. How far away should you be from the ground before? Why did you say the questions that are correct? Oh, it's because a lot of the students got it wrong, right? I'm just picking something that everyone got it right. Got it wrong, sorry. Okay, so I need to be at least how many meters away from the ground? Now, take note, I can climb up 4 meters in the daytime. So as long as I can reach 8 meters by climbing 4 meters at most, then I'm fine, right? So 8 minus 4 equals to 4 meters. So I need to be at least 4 meters away from the ground the night before, right? So if I'm at 4 meters, then just like the next day, I just climb 4 meters and I'm out. If I'm above the 4 meter mark, then the next day, I don't need to climb 4 meters to escape, but I can escape sooner. But if I fall below the 4 meter mark, then I can't escape in time during the next daytime because 8 meters is too far for me. Right, so I need to be at least 4 meters away. What if the snail fell again? The snail need to fall after it climbs 4 meters, right? If it's within 4 meters, I'm fine. Now, this is the minimum height, right? The minimum height is 4 meters. How many whole days are needed at least to reach the minimum height? So this involves a concept that I have taught you last week as well. Every time the snail goes up 4 meters, it will come down 1 meter. Every time plus 4, it will minus 1. Every time plus 4, it will minus 1. Right. So this involves a concept called the net height. After one whole day of rising and falling, what is the net height? The net height that the snail has climbed will be 4 minus 1 equals 3 meters. This is per whole day, right? But then I need to climb 4 meters in total. So what I can do is I can do 4 divided by 3, which is 1 remainder 1. So does that mean I need 1 remainder 1 whole days? Oh, it is not question 23, yes, because it's the warm-up for question 23. I can't say 1 remainder 1 whole days, right? So let's imagine, right? Let's discover a bit further. The first one, this is the quotient. It refers to how many whole days that I can climb at least. But remainder 1 at the back, this means I need 1 more meter extra, right? That means after 1 whole day, I am still 1 meter away from the minimum height, which means 1 whole day is not enough for me to reach the minimum height. I need another whole day to cover the 1 meter extra. So whenever you see the remainder here, you need to keep the quotient and plus 1. The next whole day is used to handle the remainder. So you can cross the remainder and enter the minimum height. So you will need 2 whole days at least, 1 plus 1. Okay? And that means how many days does the snail need to climb out of the burrow? Just now, we need 2 days to reach the minimum height. Now, what about the days needed to climb out of the burrow? Now that I have already used 2 whole days to cross the 4 meter mark and arrive at somewhere above, right? For my CO kids, this is called the sprint zone. Right, now that I have entered the minimum height, I just need 1 more day to shoot out of the well. In other words, after 2 whole days, I reach the minimum height. I need 1 whole day, 1 final day to shoot out and escape without falling. So I will need 3 days. All right. So when there's a remainder, right, that means whatever whole days you have in the quotient is not enough to handle the minimum height. To reach the minimum height, you need 1 extra day to handle the remainder. Okay, and with that, finally, we enter question 23. Right, Dr. Strange is conducting an experiment with bacteria. After observing for a few days, he found that each day 11 bacteria died during the daytime and 5 new bacteria was reproduced at night. Dr. Strange started the experiment with 200 bacteria in the beginning of day 1. So at the start of day 1, he has 200 bacteria. How many days, including day 1, will need for the number of bacteria to reach 0? So let's observe what happens, right? At first, it's peaceful. There's no deaths. But then on Thursday, I have 11 more deaths in the day and then 5 less deaths at night, right? So actually, after one whole day, I have 11 deaths and then 5 are reproduced, or you can think of it as them coming back to life, right? So we want our number of bacteria to reach 0, which means we want to reach 200 deaths altogether. We want all 200 bacteria to die, right? Now, after one whole day, right, the daytime there are 11 deaths, but then 5 revive themselves at night or reproduce themselves at night. So the net number of deaths each day is just 6 deaths. There are only 6 deaths each day, or each whole day, right? Let me write out a little note, each whole day. Right. So as we plus 11 minus 1, plus 11 minus 5, plus 11 minus 5, this question is like the snail climbs our problem because it keeps on going up, going up, going up, going down. Right. And when you think about it, right, I have said just now, in snail climb well problem, which day is special? The last day is special because on the last day, which I don't know which day it is, but it is definitely the last day, right? Only deaths will happen. It will be when all of the 200 bacteria have died, and once they die, no more bacteria can reproduce, right? So if and the last day, only deaths has happened. Let's think about it. On the last day, how many deaths can I increase at most? Right, just like thinking about it, at the last day, how many meters can the snail climb at most? You look at the increase, right? I can increase 11 at most, so at most 11 deaths can happen on the last day. So if you remember this, right, at the previous question, I said we can climb at most 4 meters, right? We can climb at most 4 meters. Then the first question I asked is what is the minimum height, right? To reach the last day, right? The night before, at least how many meters away from the ground am I? So likewise over here, to reach the point where 11 deaths is enough to kill the entire population, at least how many deaths do I need before the last day? What is the minimum height? The minimum height is just the total height that I need to reach, subtract the maximum rise I can have in a day, which is 200 minus 11 equals 189. Right? Yes, it's 33, correct. Okay, so yeah, so you take the total number of deaths you need minus how many deaths can you increase most in a single day. So 189 deaths must have happened before the last day, at least, right? The minimum height is that. So now you just need to find what is the number of whole days needed to reach 189 deaths at least, right? So to do that, you will need your net day, your net height. And we found our net already, which is 6 deaths. Rise, R-I-S-E. It means increasing. Okay, so every day's net death is 6. So we can just take 189 divided by 6, which is equal to 31 remainder 3. Now 31 means 31 whole days, but after the 31 whole days, you are still 3 deaths away from reaching the minimum. So that means 31 whole days is not enough to reach 189 deaths at least. You will need 31 plus 1. The plus 1 is to handle the remainder. 31 plus 1 equals 32. Whoops, let me write clearer. 32 whole days. So you will need 32 whole days to reach 189 deaths at least. After 32 whole days and nights, you have reached 189 deaths. So you will need one last day, right? Remember in the previous question, you will still need one last day to shoot to the peak, to shoot to the final height. So the number of days needed to reach 200 deaths in total is 32 plus 1 equals 33. I will need 33 whole days altogether. Okay, first find the net number of deaths as well as the minimum height, right? Then to find the number of whole days, you do division. But if there is a remainder, that means 31, your quotient is not enough. You need to plus 1. Plus 1 to reach the minimum height to be able to shoot up without falling the next day. But then shooting it up itself, it needs one more day. So you need to plus one again, right? So this is a more trickier version of snail climb as well. Hopefully this is clear for you. Okay, if not, you can always refer to my solutions later. And then let's enter question 24, right? Question 24 is about excess and shortage, right? I believe most of you have learned of this before, right? But it's more about comparing the difference in different scenarios. Like what's the difference in the results in two different scenarios, right? So first, let's read the question. Chris is walking to school from home. If he walks 80 meters every minute, right? He walks 80 meters every minute, he will reach school 6 minutes before the lesson starts. If he walks 50 meters every minute, let me use another color for this scenario. If he instead walks slower, 50 meters every minute, he will be late for 3 minutes. Then there are how many meters from Chris's home to school? All right. So in this case, right, we realize that every minute we walk for a certain distance. Every minute we walk for a certain distance. The two scenarios have a different result, right? Because the distance they walk every minute is different, 80 versus 50, and whether he is late or not is also different. But let's find out what is the same first. What is similar in these two scenarios? In these two scenarios, okay, the similarity is, first of all, the school to home, the distance is the same, right? So this is the same. The school and the home, the distance is the same. Second, the time before lesson starts, right? So in these two cases, the time before lesson starts is the same, right? Chris is walking to school from home, right? He is starting to walk at the same time point, just that if he imagines he walks at different speeds, it will take him different times to reach the school. So let's think about the two cases now. Case one, let's assume, right, the time before the lesson starts is some number of minutes. And in every minute, first minute, he walks 80 meters. Second minute, 80 meters. Third minute, 80 meters. Every minute, he walks 80 meters until school starts, right? He walks until school starts. So here, the key point is we want to make it until the school starts. Okay? Let me write it a bit more clearly. Until school starts. All right. Now, he said he came to school 6 minutes before the lesson starts. So he still can walk 80 meters for 6 more minutes, right? So imagine he reached 6 minutes before lesson starts, right? So he has to stay at school. But if he could still continue walking, he could have walked for another 6 times 80 meters, right? Because 6 minutes, every minute he could walk 80 more meters. So he could walk for another 6 times 80 equals to 480 meters. But some of you have said you can use X for the number of minutes. Can, right? You can use algebra for this as well, right? So he could have walked for another 480 meters because he's early for 6 minutes. If he continued walking for these 6 minutes, he can walk past the school and walk for an extra 480 meters. He could walk past the school and continue for another 480 meters. But what about case two? In case two, right, he walks 50 meters every minute. Every minute is a 50 meters, right? By the time lesson starts, he will be late for 3 minutes. That means he still needs to walk for 3 minutes at this speed, 50 meters per minute, before reaching school. So at this point, how many meters is he away from school? He is still 3 times 50 minutes, right? Because 3 minutes, every minute, 50 meters. 3 times 50 equals to 150 meters, right? So he will still need to walk another 150 meters. So in these two scenarios, the total distance that he has covered or the total distance he has walked is different. And what is the difference, right? This is an important step, right? If you have to take away something from this question, it will be how to find the difference in this case. On one case, I can walk 480 meters extra from school, right? I walk for an extra 480 meters. In the other case, I am still 150 meters away from school, right? So on one case, right, I'm drawing the picture here. Let's say the school is here. Let's say Chris is here. On one case, which is the red color case, right, 80 meters per minute, Chris can walk 480 meters beyond school. He can walk an extra 480 meters. It's like an excess, right? Too many meters. On the other case, he is still 150 meters away before reaching school, right? He is short of 150 meters. So to find the difference in the total distance walked, right? One is beyond, one is just before. I shouldn't subtract. As shown in the picture here, I should add up the distances. Extra 480 minus shortage 150. So 480 plus 150 is 630 meters, 630 meters. Right. Now, why is there a difference in the total distance walked? Why he couldn't cover extra 150 meters and also go beyond for 480 meters? Why is there such a difference? Well, that's because every minute he was slower in case 2. How much slower was he? Now, this step is pretty easy, right? You just compare 80 meters in a minute, 50 meters in a minute. So the distance walked has a difference of 30 meters per minute. So think about it. Every minute I walk 30 meters fewer. Every minute 30 meters fewer, 30 meters fewer, 30 meters fewer. This caused a total difference of 630 meters. Every minute my difference is 30 meters. Every minute the gap is 30 meters. Every minute my gap increased by 30 meters. How many 30 meters do I need to have a total gap of 630 meters? That will be how many minutes there is until school starts, right? How many minutes is there until school starts? So that will be 630 divided by 30, which is 21 minutes. All right. And with that, we know that it is 21 minutes before school starts. So we can use this time point to find the total distance to school using the 2 cases on top. In the first case, he walks 80 meters per minute and he is 6 minutes early. So he only walked for 21 minus 6, which is 15 minutes. So 80 times 15 is 1,200 meters. So that's one way to get the answer. And the other way is to take note that if he walks 50 meters per minute, then he will be late for 3 minutes, which means he still needs to walk for 3 more minutes before reaching school. So he walked for 21 plus 3, which is equal to, whoops, let me write better, 21 plus 3, which is equal to, again, 1,200 meters. Right? So that is how we find out the distance. Now, this question might be slightly difficult to understand at first. I hope that your key takeaway is how to find the distance or the difference in the 2 cases. If there is a walk too much in one case, there's a not enough in another case, right? Excess and shortage. To find the difference, you add them, right? One is you walk too much, one is you're walking not enough. Excess and shortage. Then to find the difference, you add the excess and shortage amount. All right, so this is question 24, right? And finally, right, it's evil teacher time, right? This question is tailored by teacher Yonglam, okay, to see how many of you could stretch yourself and try this question, right? It's a new operation that is defined such that 12 perpendicular, perp 6, right? This is called perp. It's a name I give to it, right? 12 perp 6 is 0. 49 perp 7 is equal to 0. 12 perp 5 is equal to 4. 49 perp 9 is equal to 20. Now we want to find the pattern and find out what's the value of 94 perp 7. Okay, so how do we do that? Okay, so here's a hint, right? Whenever we see defining operations, we try to find the pattern, right? Or if we can't even find the pattern, it's okay. Try to see, is there any 2 equations that look similar to each other? Is there any 2 equations that share something common? Right, what do you notice? What is suspicious? Right, can you realize what is suspicious here? The 2 equations? Right. I see that there are 2 equations with the result of 0. Right, 12 part 6 is 0. 49 part 7 is 0. They both result in 0. So we need to look at them a bit closely. Why could they give me 0? What is so special about each pair of numbers? What is so special about them, right? 12 and 6, what's the relationship? 49 and 7, what is the relationship? Right? Can anyone tell me? I see someone already told me in the YouTube chat, right? What do you notice? Right. Some of you have noticed that 12 divided by 6. 12 is divisible by 6. 12 is a multiple of 6, right? When I divide it, I get 2 with no remainder, right? Or I can say remainder 0, right? No remainder or remainder 0. Then 49 divided by 7. Again, 49 is a multiple of 7. So I have 7 remainder 0. Okay? Now, here's the thing though. What's so special? Do you see another 0? Do you see another 0? Right, so maybe it is the remainder that I am taking over here. Maybe, right? Let's just guess. Sometimes you need to make educated guesses. And once you make this guess, don't forget, test it on the other equations to see if it's true or not. Right, for example, 12 divided by 5. What is the quotient? What is the remainder? It is 2 remainder 2. And 49 divided by 9, that will be 5 remainder 4. Oh no, right? It's not exactly the remainder, right? Because you see the third equation, remainder 2, how come I get 4? The fourth one, remainder 4, how come I get 20? How come? Right? Then let's think about it. What should I do to the remainder? 0, right, on top, to keep it 0. And then now you realize, 0 multiplied by anything is 0. Right, 0 multiplied by anything is 0. And then what if I do 2 times 0? It's 0, right? 7 times 0 is also 0. Right, maybe you can use these two to check now. What about 2 and 2? 2 times 2 is 4. Oh, it's 4. It's 4. Okay, and then let's try again. 5 and 4. 5 times 4 is 20. It's 20. That's what I want. So from here, you found the pattern, right? We found the pattern. The pattern here is you take the bigger number at first, divide by the smaller number, find a quotient and remainder. Then you multiply and see what is their result. Okay, so that's the pattern. Remember to check it with all the equations. Whenever you see a defining operations problem, right, whether it's in competitions or exams, test it with all the equations to see if your pattern applies. It's true for every equation. Then finally, let's try 94 per 7. So we do 94 divided by 7, which is 13 remainder 3, right? I see someone very kindly wrote the workings for me. Thank you so much. Then we take the quotient and the remainder and multiply. 13 times 3 is 39. And with that, I have figured out my answer, right? It is 39. Okay, so that is it for this problem. So whenever you see a defining operation or number pattern problem, please try to look for some common numbers. Look for something weird. Is there something that is common in two equations? And try to work from that. And remember, if you found a pattern or you think you found a pattern, test it with all the examples to see if it is true. All right, and this is question 25, which is the last question